If you've watched any of my videos that include data access, you're probably familiar with Dapper. Dapper is a micro-ORM built by a team behind Stack Overflow for the purpose of getting data into and out of databases. It's quick, it's easy to use, and it's easy to debug. In this video, I'm going to cover some of the advanced scenarios that you can use Dapper with, including user-defined table types, transactions, and multiple datasets, and even more. Now, if you're new to this channel, my name is Tim Corey, and it's my goal to make learning C# easier. There are a number of ways I try to do that, but the main one is this YouTube channel. I also run a training website where I have courses that will help you out as well. If you come across a topic in C# or a related area like SQL or Git or another that you'd like me to cover, let me know and I'll add it to my suggestion list. Most of my videos are directly based upon feedback from my viewers. Okay, let's get started in Visual Studio. This week's source code is a bit different than most. The code's already written, now let's be going over it. There's a couple reasons for that. First, this code comes from my conference talk at the PASS Summit. We won't be covering everything from that talk, but I've added some more content based on the feedback from that session. Second, instead of typing as I talk, I'll be walking you through the completed examples. That'll allow me to show you the differences rather than just typing similar things multiple times in this video. Now, if you want this source code, follow the link in the description to download it and to get other resources. Okay, so we have a couple things in here. We have this is our SQL Server Data Tools, and if you're not familiar with SQL Server Data Tools, I've got a video on that on this channel. And this allows me to create a small database that I can give you that you can deploy and work with right away. So this is a really handy little tool that I'm going to be using in a lot of my videos that need databases. So just to kind of show you what it does, we've got a couple of tables. Tables, there we go. We have the person table and we have the phone table. So person has ID, first name, last name, cell phone ID. And then the phone table just has an ID and phone number. Now we have a couple of store procedures. The first one, the easiest one, is this search, which just takes a search term and it looks for a person in the table where their first name or last name is like that search term. And then we have a little bit more complex one in the SP person underscore insert set. Now this is one we're going to cover today, and it uses a UDT, or user-defined table type. And what that is, and I'll show you right here, what that is basically you create a type, kind of like string or int or something else, but in this case, in SQL, it's a table. So that's the type. So create type, the name, and as table. And what that allows us to do is define a new data type that we can use to pass into store procedures. So if we look, notice it's first name and last name, the only two columns we have in this UDT. So in here, we're saying SP person insert set, we take in that table type. So what that allows us to do is pass in, instead of passing in one row at a time for an insert, so you call this store procedure like 5 times for inserting 5 records, instead, we're going to insert into the table a whole table's worth of data. So we'll just give me the first and last name from the people variable, which is that UDT. So we'll see that in a little bit. Now, one last thing I want to show you in the SQL Server Data Tools project is this right here, load data script. So what this does, basically it's set up. Okay, it's not something you have to know the syntax for. This is it just works, and so we're gonna leave it alone. But what it does is it clears out the person table, and then it inserts 5 records in that table. And then it also deletes everything from the phone table, and then inserts some values, and then it wires them up to 2 users, so that 2 users have phone numbers. So it really just sets your data up. We don't have to worry about it, but just know that it's there, and that's the kind of magic that creates the tables with data already in them. So we just run this publish script. So double click here and say publish, and that will publish our database for us. And we should see over here in our database list in SQL Server Object Explorer that we have Dapper DB. And if we open up the person table and view the data, we'll see we have those 5 records, and there's the cell phone IDs for Tim and Jane. Okay, so that's the SQL project. Now, the other project we want to look at is let's look at the helper project first, just so we can get out of the way. It's pretty simple. We have 3 models. So we have the phone model, which is just ID and phone number. We have the person model, which is just first and last name. We also have this full person model. And this is the one we're going to use today. It inherits from person model. So it has the first and last name, but it also has the ID, and it also has this cell phone, which is a phone model object. And that's one of the things we're going to do today as well, is we're going to populate this full person model from Dapper, which means we have to populate this object model inside of our main model. So we'll see how to do that. And we have tools down here, which is just get connection string. That's all it does. And that connection string, of course, comes from the app.config, which is pointed at our local DB. So it should just run right out of the gate as long as you built that database like I just did. So now let's close all of this out and look at our demo 1, which we're not going to cover today. This is the basic stuff. And this you've probably seen before, but if not, these are all labeled. So reading with Dapper, there's a basic write, writing a set, basic write a set. There's some pretty simple stuff here and some a little bit more advanced, but it's still kind of just Dapper basics. So if you have a question about how to read with anonymous parameters, well, there's your example for you. And you come down here and open up this source code and see, well, you just do this right here and you pass it in. So it kind of explains how you do it. But this is not what we're going to cover today. Instead, we're going to cover demo 2, which is the advanced stuff. So in here I have a number of methods, and each one does something a little different. So we're going to start from the top and move our way down. So map multiple objects. What do I mean by that? Well, this is that tricky one where we have a full person model, and you want to populate it, including that phone model inside of it. So here is our SQL statement. So let's read this through first, just so we understand what it's doing. Let's make it a little more readable. There we go. So we are selecting PE.star and PH.star. What are PE and PH? Well, those are aliases for our tables. So from dbo.person, that's one of our tables. We named that, we aliased it as PE. So person is PE. So give me all the people columns first, and then left join on phone, which means we're still going to get all the people records even if there's no matching phone. But if there is a match, then we'll have values in these columns. And that link is based upon the cell phone ID matching the ID of the phone table. So let's just look at what this would be. Let's just pin this over real quick, and we'll do a quick query here. So let's just click here and create a new query. And so what we're doing is we're saying select PE.star, comma PH.star from dbo.person PE, inner join dbo.phone PH on, let's do the on down here, on PE dot cell phone ID equals PH dot ID. So that's our query. And if we run this, the results are, whoops, I didn't inner join. This is kind of a good example. So an inner join will only give me 2 records because there's only 2 people that have cell phones, and that's Tim and Jane. But with a left join, and if I run this, notice I get all the records from the person table, all 5, but I get nulls here if they don't have a cell phone. And that's what you want. We want to have nulls here if they don't have a cell phone, but if they do, we want the ID and the phone number. Now, really, we don't need this column, the cell phone ID, or the ID column. We just need the ID column for the person, and then the first name, last name, and phone number. But that's okay. We can deal with having extra information because that we will capture this, and our model kind of likes it. So that's the call to SQL. But how do you do this in Dapper? So I already have a connection open. Let's just unpin these. I already have a connection open to Dapper. And it gets my connection string, which is that helper method. And it says, okay, I want to do a query, which we're used to. But we're used to passing in one type. And say, okay, there's my model. Give me a list of that, or actually an IEnumerable of that. But in this case, we're passing in 3. And then, we'll skip over that for just a minute. Then we pass in our SQL statement. Well, we got that. That's right here, piece of cake. And then we have this mapping right here. And that's a little confusing. So let's talk through what this is doing. So it's saying we have 2 models that are coming back from this SQL statement. We have a full person model and we have a phone model. Okay, so that would be the full person model. This is the phone model. These 2 are coming back. But then the result we want is to have an IEnumerable of full person model. So that's the end result model. We don't want phone model with full person inside of it. We want full person with phone model inside of it. So that tells Dapper, okay, here's the priorities here. We want these 2 models, and this is the resulting model. Now, what we're saying next is, how do you map these 2? So we're saying, okay, this is a anonymous method. It's a lambda. Okay, so we have the arrow function here, or the equal to greater than. And so we're declaring these variables. And these variables can be anything you want. It could be X and Y. They could be anything. But I decided to call them person and phone, because person and phone, that's what it maps to. And it makes sense as far as reading it to go, okay, instead of saying X dot, I can say person dot, and understand this is the person model. So we're saying pass these 2 variables in. These are the 2 different models that are on our select statement. And then we say, here's how they map together. Person.cellphone, that's the parameter, or that's the property that has our phone model. Okay, that's where it lives, the phone model lives. Person.cellphone equals phone. So put phone into the person property called cell phone. And then return person, because that's what you want, the full person model. So we're returning a full person model object once we put the phone into the cell phone property. Okay? I know it takes a little bit of time to kind of wrap your brain around it, and I do think that having an example helps. And then the other thing that helps is seeing it in action. So let's do that. So we have our for each. So I used var. I don't always use var, but I'm using var in this project because it's just easier in typing all these things out. But if you mouse over, it does say full person model. So for every full person model P in the people list, that's what gets returned from Dapper. We're going to loop through and say what's the first name, what's the last name. Cool. And then the cell, if there is one, give us the phone number. And that's the tricky part, because remember, there's 3 records that have nulls for cell phone. Okay, so we go back over here, we'll see null values for Sue, for George, and for Fred. Well, what do you do with that? That's when we come over here and it does a mapping, it takes whatever's in phone and puts it in a cell phone. Well, there's nothing in phone. And that's where it creates a null object and puts it in cell phone. So that's why we can't just say p.cellphone.phone number, because there might not be anything to read here. It might be null. So therefore we have this question mark at the end. So what that does is it says, if this is not null, then do the rest of the stuff. But if it is null, stop here, ignore it. So p.cellphone, if it's not null, then give me the phone number. Otherwise, nothing. So let's run this. Notice I've uncommented just this one. Let's run this and see what it looks like. And there we go. So Tim Corey, cell phone, 555-1212. And yet Sue Storm, no cell phone. George Smith, same thing. Jane Jones does have a cell phone, but Fred does not. So that's how we map those two objects together. And if we moused over them and paused and looked at the object, we'd see the full populated object, including that cell phone property. Okay, so that's how you map with properties inside. Gets a little bit more tricky, but at the same time, once you get the pattern of these two objects, and then this is what it goes into, you're good to go. Now let's take it up just a little bit, be a little bit more complex. And that is, what if you said, that's great, but we didn't pass any parameters in. So it's the same exact call. The only difference is we're passing in a last name, and we're going to use that parameter. So create an anonymous object, P, that holds last name equals last name. Okay? And in fact, let's actually capitalize that because last name is capitalized at last name. So we're passing in last name, and so an anonymous object allows it to create any property we want. And it just says, okay, sure, I'll take that. So I created this property called last name. And then I assigned it the value that was passed in the string parameter. Now in my SQL string, what's changed is I have this where statement, where pe.lastname equals, and then at last name. And this is a parameter that can then be used by Dapper. So Dapper will take our parameter list, that's our anonymous object P, and it'll say, do I have a last name? I better. Well, yes, I do. Take this value and put it in this SQL string safely. This is what's called parameter injection. It's different than just saying equals and then saying plus, last name, and closing it out. That's not safe. And the reason why is if I pass in SQL code in this last name parameter, that would cause this SQL statement to crash if I didn't use parameter injection or SQL parameterization. So this is the way you want to do it. You want to create parameters and then pass in those values. Don't put it directly into your SQL string. So the only difference in this call down here, we still have the same three models being passed in. The first one, the second one, and the resulting one. We still have the SQL statement. We still have this mapping here, it's the same mapping. And the only thing we add is comma and our parameters. That's it. And so the same thing will happen. Let's make sure we have it. Yep, it's commented. And I'm passing in Corey. So if we run this, there we go. Corey. Whoops. So it's not much difference, okay? But I did want to show you this because I want you to see it doesn't have to be a whole lot of added complexity once you get to a certain point. Yes, it starts off a little complex with this stuff, but then adding parameters is just adding the parameter passed in. That's it. Okay, so let's move on to what if you have multiple result sets coming back. So you're returning maybe 3 different tables or 2 different tables. What do you do then? Well, let's look. In this case, our SQL statement is select star from dbo.person and select star from dbo.phone. So we're going to run both. So what we did here is I created a list of person model, which would be what would hold this. I created a list of phone model, which would hold this. And then I said, and this is all inside my connection, I said using var lists. Okay, that's the SQL mapper.gridReader. That's why var is easier. But var list equals the connection dot query multiple. So we're telling it, hey, you know what? There's actually multiple things coming back, not just one. So we pass in just our SQL and say, okay, now that you have that, the next thing I want you to do is I want you to map it out. And so here's our mapping. Lists, which that's the variable that comes back from this query multiple, list.read, and pass in our person model to list. So it says, give me the people first, because that's the first one in our SQL call. Next, give me the phone model. It maps that out as well. And that's all there is to it. Okay, so what we're going to do next is we're going to loop through each person and print them out. And then loop through each phone and print that out. Let's just make sure that does in fact work. And yes, it does. There's all the people. There's the phone numbers. So those are the two different lists we pulled back with one query. It's kind of efficient. If you have multiple result sets to return, go ahead and return multiple. And then just grab each in turn. Now, one of the questions that's come up that I want to point out is the order here does matter. So you cannot switch the order here, phones and people, because person / from dbo.person comes first. Therefore, the mapping to person has to come first as well. So you have to match up the order to what the order is in your SQL statement. Now, again, that's great, but we're not passing in any parameters. No worries, I've got you covered. We're going to pass in last name of Smith and a phone number partial of 1212. So let's look at that. So we're passing in last name and partial phone number. And the reason I did this is because I want to show I'm putting a parameter here for the DBO person, so where last name equals this last name. And then I'm doing a different parameter for dbo.phone, where phone number like that partial number. Now, just to be clear, I could use at last name more than once in different SQL calls. That's not what I'm trying to say here. You can use the same parameter in different calls. But you can also use different parameters in the different calls, and it's okay as well. So nothing else has really changed here, except we have this var p equals new anonymous method, or anonymous class, sorry. We have first name and partial phone number, or last name and partial phone number, which we're going to map to last name and partial phone number. And we have that query multiple, and we have a SQL statement, and we're just comma p. That's our parameter list. That's the only difference, really. This right here, and of course our SQL statement has parameters. Let's run that again. And this time we have person George Smith and person Fred Smith, and the phone number is 555-1212. So there's our matches. Okay, so again, once you get the base call down, adding parameters is just adding it on to the end. That's really it. Next, what if you want to pass out parameters? So output parameters. So you have data. Oops, there you go. You have data inside of your SQL and you want to get information out. For example, and this is a pretty common one, when you insert a record into a table, one of the things it does is it usually, if you have an auto incrementing ID field, is it increments that ID. You don't know what that number is, but it creates a new ID number for this new person, for instance. Well, SQL has this thing called at identity. And what this does is it gives you the last identity that was created in this transaction, or in a transaction. Now, just in case you want to know, at identity is based upon the scope of the server. So if you had some replication or trigger issues, there's a whole road you can go down of, well, is it the right identity to get, or is it scope identity, or is it something else? For our purposes, this works great. And for most purposes, it'll work fine. So this gets that identity ID. So it gets the number of in the person table of our ID. Now notice our ID column is 1, 2, 3, 4, 5. In theory, number 6 is the newly inserted record. In theory. It could be that if you delete row 6, it's actually 7 or 8. So you don't know for sure. And this way it gets that identity and it puts it into the @ID property, which we passed in, but we said it's direction output. And so what that means is it's going to get the value back out after this call is made. So this right here, select @ID equals identity, it puts the identity value into the property, and then when we execute this, that right here will have the new value instead of 0. So let's walk through this. We create dynamic parameters, which this is a class that comes from Dapper and allows us to do some more advanced stuff, including specifying types, but in this case, we're specifying the parameter direction. So we're saying it's an int32, which it typically is for an identity column, and the direction is output. We are passing in first name and last name, so those are inputs, which is the default. So there's our statement, insert into, and then once we insert, we get that identity, and then we execute like normal. So SQL and parameters. That's it, we're executing. Now, once we've executed, we can say P, which is our dynamic parameter list, P, get, and it's of type int. So it's going to make sure it's that type when it comes out. Get the @ID value, which @ID, which starts off 0, but it's going to get the value passed back from this insert statement. Get that value. And what we'll do here is we'll say the new ID is, and give that ID number. But in a real application, what you do is take that identity and use it for subsequent inserts. So for example, if you insert a person and then you have their cell phone number, well, you might use that if that ID was used in the cell phone table. Although in our case, it's the opposite. So the first insert you do would be in the phone table, get that ID, and then when you create the person, you could pass in that cell phone ID since it's theirs. So, but let's look at how this works just to see it. Let's run this. And it says the new ID is 6. And I say of course because we haven't done any kind of messing around the database, but we will see later on how that can get skipped. So there we go. ID is 6. And if we come back over here and we run this again, we'll see the results. Oh, I've got person highlighted. There we go. So Peter Parker has been inserted with no cell phone and his ID is 6. So there we go. So that's how we can get a value back, or values. It doesn't have to be as 1. You can get 2, 3, 4, 5 different values back if you want to. All you need to do is declare them as output, fill them up somehow inside of your SQL statement, and then use this code right here to get them back. All right, transactions. Now, transactions typically, it's a little more advanced SQL thing, but at the same time, it's something really important to do. So the basic primer on a transaction is this. Say you're a bank application, and you've got a person's checking account and their savings account. And the person comes to you and says, I want to move $100 from my savings account into my checking account. And your software says, great, I'll do that. And so it withdraws from the savings account. Cool, so the savings account value goes down by $100. But then the application crashes. Where is that $100? Because you didn't yet insert it into the checking account. And so it's been taken out of one account, but not put into the other account. So it's basically just missing. And no one likes a missing $100. That's where transactions come in. A transaction says, we're going to do multiple operations. But if at any point we don't say that, yes, we're all done, then we're going to roll back that transaction, which means it would put the $100 back into the savings account. So on a normal transaction, we'd open a transaction up, say that's at the start. Then we say take out $100 from the savings account. And then we do an insert into the checking account for the same $100. And then as long as those two transactions happened successfully, we'd say commit that transaction. And then as a whole, those actions would be completed. Therefore, you never lose your $100. However, if we started the transaction and then we took out the $100 from the savings account and the application crashes, that transaction would never get committed. Therefore, it would get rolled back. We never actually do that action. So that's a basic primer on transactions. Let's see how we can use that inside of C#. So here I've written some bad code, all right, which wouldn't be the first time. So we have our opening connection to SQL. There's our connection, and I have my parameters, which I've created dynamic parameters here and just had first name and last name. And my first thing I'm going to do with my SQL statement is insert into person, first and last name, these values. Now, just so you can see, the values are Mr. and Nobody. So we're going to create Mr. Nobody in the person table. To use transactions outside of SQL in C#, we say CNN, which is our connection, .open. So you open the connection first. And then we say using var trans, which var is actually an IDB transaction, equals CNN.begin transaction. That says, okay, we're going to start using a transaction. Now, again, this is a C# thing. We're inside a using statement. Remember, even if the application crashes, it's going to close this connection either down here at this closing curly brace, or if the application crashes. Now, if that happens, just so you know, it's going to roll back the transaction. So if we don't specifically commit the transaction, it will roll it back either at this curly brace or if the application crashes. So we're safe. So now down here, we're going to execute our SQL. There's our SQL right there, and then our parameters, and we're passing in the transaction. And we're going to grab how many records were updated. In this case, it should be 1. So records updated should say 1 because we're going to insert 1 record into the dbo.person table. The next thing I'm going to do is I'm going to try to do something. Put in a try catch. So I'm going to try to execute this SQL statement, which is update dbo.person set ID equal to 1. Now there's a couple of problems with this SQL statement. First of all, the ID table is our auto-incrementing value. That's not something you should try and insert values into. Technically you can if you set certain things up, but you shouldn't. Also, that column can only have unique values because it's an identity column. Therefore, you can't have 2 values with a 1. Also, notice there is no where clause here. This is a very common mistake. So with no where clause, I'm going to update every single record to have an ID of 1. This statement will not run. In fact, if you wanted to, we could run this over here and see that cannot update identity column ID. So it's saying, nope, you just can't do that. So this statement should crash. Notice I'm passing in the transaction trans. So if it succeeds, we're going to do trans.commit. Now notice I'm doing this in a try catch because if SQL has an error, it will come back through Dapper as an exception. So I'm catching that exception. I'm going to write out what the message of that exception is, and I'm going to roll back the transaction. So if it works, I commit. If it does not work, I roll back. Now at the very end, I'm going to call the map multiple objects method. And the reason I'm going to do that is because this prints out all of my people and any attached cell phone numbers. So that's just an easy way of showing, is Mr. Nobody in the database? So let's run this. Make sure it's uncommented. Let's run this and see what we get. Records updated 1. So it did insert Mr. Nobody in the database. Error, cannot update identity column ID, which that's the same error message we got in the query window over here. Now we print out all the people in the database, and notice Peter Parker is the last one. Mr. Nobody's not here. So it said we updated one record, which we did. We inserted Mr. Nobody. But because we ran a bad SQL statement, it rolled back that transaction, and so Mr. Nobody is no longer in this table. Just to show you what happens if it works, let's just say that we'll set the last name. I know I'm going to mess up my data, but that's okay. Set the last name of every person to 1, which will work. So we'll commit the transaction. Let's run it again. Records updated 1. We have Peter. Then we also have Mr., which 1 would be nobody, but now it's 1. So that worked. So it committed the data to our database. Okay, so that's how transactions work. The keys are, don't just leave a transaction open forever, which is why we have this using statement here. Also be careful of things like if you do one thing and then do a whole bunch of processing in between before you do your second transaction, that's not usually good either. You don't want to keep a transaction open for long. So be careful of that from a performance standpoint. You don't want to spend a lot of time doing work if you can avoid it. If you can't, you might want to think of different ways of going about this rather than opening up a transaction and just doing a ton of work. So that's how you do a transaction in Dapper. Let's get to the big one. Insert dataset. So this right here, the first thing I want to show you is get troopers. So I've got a whole bunch of, let's call them stormtroopers maybe, with their ID. So trooper and their ID number. So what I've done is I've created a data table. Now, a data table is part of ADO's stuff. We don't typically use data tables much anymore, especially now with Dapper doing all our mapping for us. But in this case, I'm creating a data table in memory. That's called output. So I add my columns, first and last name, and their types. So it's type of string, type of string. So that's the 2 columns, and that matches up, just so you're aware, that matches up with my UDT. Okay, so first name and last name, they're both string types. String is the equivalent of varchar and varchar in SQL. So first name and last name, and then here's the values. So we're going to add a row, first name, last name, all the way down through. So it returns a data table. So the first thing I do is I get my list of troopers. There's 9 of them. And then I say, create a new anonymous object, P, or anonymous class. And then inside here, I'm going to have one property, people, because that's what the person insert set takes. And that's right here. It takes people of type basic UDT. So people, and I say, here's my data set, or data table, and I say dot as table valued parameter, and I say that's the UDT to map it to. So in this case, it's basic UDT, which that's what we're passing in. So my data table, use the extension method as table valued parameter, and pass in which UDT we're mapping it to. Then everything else is just the same. So we have cnn.execute, our store procedure, our parameters, and then I'm telling it, yes, this is command type store procedure. So that's it. That's a normal execute statement with a store procedure. The only difference is this right here and the fact that it's a data table that we're passing in to our property rather than an actual value, one value. So in this case, we're going to pass in 9 troopers into the store procedure. Now, why is this important versus a normal insert? Well, a normal insert, if we wanted to insert 9 people, we would do it one row at a time, which is fine for small things. But if you get into wanting to have large chunks of data inserted, it might be more performant to, instead of doing it one at a time, to do it all at once. This execute will call this store procedure once, not 9 times, just once. And it passes that bundle of data in. Now the insert statement takes that bundle of data like I showed you earlier, and it says insert into dbo.person, select from. So instead of saying values and then passing in values, it's doing a whole table's worth of values inserted into dbo.person. And that whole table is our parameter we're passing in. So it takes that whole table, it passes it in once, and we're going to do is we're going to capture the records affected. Because when you do a cnn.execute, normally we're only inserting one record. In which case, capturing a 1 back just tells us that it did work, but not much else. Where in this case, we're going to find out just how many records we inserted. It should be 9, I believe. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Yes. So 9 records should be affected. And we'll catalog that right here. And then we're going to, again, map multiple objects just to see those troopers are, in fact, in the database. Let's run this. There we go. Records affected 9. And there's all those troopers, none of which has a cell phone. So that's how you are able to insert a whole table at once into our SQL database. And with that, that's all of the advanced demos. All right, so what I'm going to do, I'm going to give you this code. And like I said, it's on a blog post. Oops, don't want to save that. It's on a blog post on my blog. So follow the link in the description to go get it. And just download it and try it out. Now, some of these things you're not going to use very often. If you find yourself using all these things all the time, maybe you're doing things that are a little too complex. Maybe you should try and figure out a way to do it more simply. But the problem with not doing things very often is you often forget how to do it when you try to do it. So what I would recommend is just keep this project somewhere. Put it in a file folder somewhere and pull it out when you need to. And when you want to use transactions, just go to that method and refresh your memory on how to do it. Okay? So this really is just a reference tool for later to come back to. But at the same time, it's also a learning tool as you're doing it for the first time. All right? I hope you've enjoyed this video. If you have any questions, please leave them down in the comments below or just let me know what you thought of the video. All right? Have a great day. And as always, I am Tim Corey.